As you can tell from the length of this video, this is a very brief overview of chemical reactions. I figured I'd put a picture here of some fireworks indicating a chemical reaction you've probably seen and are very familiar with. So a chemical reaction is making and breaking chemical bonds. The starting molecules of a chemical reaction are called reactants, and the final molecules of a chemical reaction are called products. Looking at our example here, the reactants are methane and oxygen gas, producing our products, which is carbon dioxide gas and water vapor. Make note of this reactants to products has an arrow pointing in one direction. Something related to biology, we have photosynthesis, which is a very important chemical reaction. Here, sunlight powers the conversion of carbon dioxide and water to glucose and oxygen. And we see our reactants on this side with the arrow pointing one direction to our products, which is sugar and oxygen. Now, something called chemical equilibrium. This is reached when the forward and reverse reaction rates are equal. This is indicated by this kind of half arrow pointing to the right and half arrow pointing to the left. This is indicating an equilibrium is occurring. Some chemical reactions go to completion where all reactants are converted into products. That's what we saw in the previous slides. However, all chemical reactions are reversible. The products of the forward reaction become reactants of the reverse reaction. In chemical equilibrium, the reaction actually doesn't stop. It just reaches a point of balance. So we see here we're mixing two things in the jar. This chemical equilibrium means the rate of the forward reaction is equal to the rate of the reverse reaction. So I don't think this is some sort of misprint where it's like, I don't really know what that is, with weird symbol. It's getting half an arrow pointing to the right and half an arrow pointing to the left, indicating there's no net change, nothing's visually changing, even though reactions may be occurring. They're going back and forth. We call this chemical equilibrium because the forward reaction rate is equal to the reverse reaction rate. There's essentially no change, no net change, even though we have an equal distribution of forward and reverse reaction levels.